From the smallest components to the largest assemblies, Autodesk Inventor is the 3D CAD software you need for everyday projects and ambitious challenges. Inventor puts powerful mechanical design, documentation, and product simulation tools at your fingertips to help you innovate with agility, collaborate effectively, and win more business. Inventor provides you with a stable and responsive environment to help you get your projects to production faster. With a complete set of tools for sheet metal, welded frames, tube and pipe, and electromechanical, and direct access to a robust content library and engineering calculators. Shave days off your projects by rapidly configuring products using iLogic design automation technology. Speed up design reviews with a cloud-based tool that protects your intellectual property. Connect directly with AutoCAD for your project workflows. And you can extend the power of Inventor with a subscription to the Product Design and Manufacturing Collection to take your designs further with 2D and 3D workflows, cloud-based design and manufacturing, factory planning, and high-end visualization. Regardless of what you make, industrial machines, conveyor systems, or top fuel dragsters, solve your most interesting problems efficiently and effectively with Autodesk Inventor.
A simple project that would have taken 4 hours, we can now do in 20 minutes. And a complex project that would have taken 2 days, we can do in 2 or 3 hours.
We design, manufacture, deliver, and install custom staircases. Every system is new for that customer, so every system is at least a 1/16 of an inch different. We're often one of the last products that gets installed in a home, and if we don't get it right, we can delay them getting a certificate of occupancy. Without iLogic, it took quite a bit to draw even the simplest of orders.
It was very disheartening how much manual labor went into it.
We could draw maybe 1 order a day. We turned to the Autodesk Product Design and Manufacturing Collection. Autodesk Inventor and iLogic has allowed us to automate the engineering or project management process.
A lot of things in stair design are repetitive tasks, and iLogic enables us to automate a lot of those so that a human operator doesn't have to get lost in the minutia. So let's say, we decided to pull a foot off of that floor, we added a wall there. I would come in and modify the environment here, tell it for length, put in either an absolute, or in this case, if they said we'd subtracted 10 inches, I'd do it. And I would just tell it to update all my glass. It's going to automatically engineer it for me. It's going to make it so that it meets all building codes that our product is certified for, and it's going to generate shop drawings and production prints for these as it goes. It's that easy.
We're manufacturing 10 systems, 20 systems a day right now. With the Inventor CAM, we take the exact model that is part of our automation that we've used to design for the customer, and it's already toolpathed. So that production engineer is just posting that right to the machine. It's a huge time savings, and it's a quality assurance As we build in more and more automation, we continue to drive down the potential errors that a user can make.
Welcome to Vero.
Thank you.
Have a seat.
We leverage the Forge viewer. It enables the customer to view on a web page on their phone exactly what we are engineering and how it will fit into their space.
This looks amazing.
We are now over 10 times the size that we were when we started all of the automation.
Then in the next 5 years, we're going to grow from $100 million a year in revenue to $500 million. Automation is critical for scaling at the rate that we're going. We would not be able to do the things that we are doing today and looking into the future without the Autodesk tools.
Ayan, okay. So, good afternoon everyone. Asking if I am audible. Audible nga ba? Will you be so kind to chat or say something in the comment section if I am very much audible? So again, this afternoon, this training is actually exclusively for our paid participants for the SolidWorks, upcoming SolidWorks Essential Training. So one of your benefits, if you are a paid participant of our upcoming SolidWorks training, we also have a free inventor training. So yung mga paid participants gets to have, I think na-assign na yung mga license. Lahat ng paid participants ay nabigyan ng Autodesk Inventor software as well. Okay, and including sa training this afternoon ay yung mga student ambassadors. So, the terms are, this training, you will receive an official Autodesk certificate of course completion. Like this. Ayan. So, all participants will receive an Autodesk certificate of course completion. Now, when we say course completion, you are required to do some tasks. So, this is not something na nanood lang, may certificate na. No, you will submit the required task. Of course, learning is doing, hindi naman watching. So again, those who will participate, who will submit the required task gets to have an Autodesk certificate of course completion. Now, this certificate is unique. It has its own serial number. You can place this on your LinkedIn profile. And of course, syempre, this is just an example. You're seeing Fusion 360. But of course, you'll be receiving Inventor coming from Inventor. So because this is of course an Inventor training. Okay, good morning from the Netherlands. So if you have someone from Netherlands, I don't know if it's good morning there, but here it's good afternoon. Okay, so this class is a follow-along class. So I am requesting everyone to do what I do. And if you have questions, feel free to message or to comment down in Facebook, LinkedIn, and YouTube. Okay, so giving you ample time, requesting everyone to start up that Inventor software. So I have gone ahead. I already have my Inventor with me. I'm gonna close this. Going back to the default mode. You can actually open. Yeah, I have multiple instances of Inventor opened here. Okay. Again, we'll be giving you some ample time. This is a follow along. And everyone is required to submit an output for you to have an Autodesk official certificate of course completion.
These cars are so violent. It's amazing how much damage we can do in 3.5 seconds.
You're going to win or lose by merely inches, thousandths, 10,000ths of a second.
Everything has to be built right. Everybody has to be on their game.
Hopefully you're on the other side of that, and you get the W.
Collada Motorsports is a professional drag racing team. We compete at 24 events across the country.
We use the product design and manufacturing collection from Autodesk. It makes our job so much easier. Not having to use multiple software packages saves us a ton of time. So Inventor is helpful because it's tied in with everything. You do all your modeling, you do your drawings. When you update in the model, it updates the CAM. So these cars go over 330 miles an hour and they travel 1,000 feet in less than 3.5 seconds. To accomplish something like that is really tough on the parts.
This is not a business where you can make a ton of mistakes.
If we don't do our job down to the smallest detail, that driver's life is in our hands. Everything has to be built right. Everybody has to be on their game.
Welcome to Charlotte's Z-Max Dragway for the 4 Wide Nationals. Got some great
safety is number one, and then second would be performance. We need to make sure our equipment's strong enough and light enough where we can outperform our opponents.
Currently, they're finishing up the track prep. We've got Top Fuel Dragsters up next for you.
At the 4 Wide Nationals, we had the Autodesk on Doug Coletta's Top Fuel Dragster. My expectation is to win every race we go to.
In lane 2, we have Doug Coletta with the Autodesk car.
So Inventor is helpful because races in our league can be decided by 1,000th of a second. So if we find something on a part to make it a little bit stronger, a little bit lighter, or a little bit better than what everybody else has, that makes us a big part of winning races.
Coletta crossing the finish line first, clocking in over 330 miles per hour.
Seeing something get made and then get put on the race car and us going out and running over 300 miles an hour, that's pretty neat to see.
Okay, so let's get started. I hope everyone has their Inventor software launched. So, of course, the high resolution recorded version of this will be distributed to our paid participants as well. Okay, so going to full screen, let's now begin. So again, I have Autodesk Inventor with me. And some of you might be tempted to, of course, select new. Okay, and create a new part. My suggestion is, of course, let's always be organized. So I have here a folder of mine wherein I prefer the files, the Autodesk Inventor files, to be created here, to be placed here. So mine, it's named as training proper. So on the address bar, okay, on yourself then, I want you to create a new folder. Let's say Autodesk Inventor 2025 training. So for me, as a personal preference, I named this as training proper. So on the address bar, I'm going to click here. It's now highlighted in blue. I want you to hit Control-C, of course, copy. Control-C, copying that location. Okay, everyone. Again, I want you to create a new folder wherein you're going to save all the related training files, inventor files here in this folder, on your own folder. Okay. What's the shortcut key for creating a new folder? It's Control-Shift-N for the PC users. Control-Shift-N. Yeah, Control-Shift-N. Okay, I'm going to delete this. I already have mine. Okay, leaving you some ample time. Shout out to Brian Jerome Mercado, Mark Anthony Arcillas, Arvin Velante, Patrick Bularon, Rayleigh Allen Esoreña, Ardre John Saldi, Neil Joshua Ruiz, Nichol Pariñas. Testing you. Okay. Again, hoping you have created. Shout out to Adam Daryl, Ashley Ann Maluluan, CJ Nicolasinto, Carlo Almira, Jan Salvatera, Gerard Lama, Juliana Castro, Carl Angelo Bautista, Mark Azucena, Reynalen Vinasoy. So, again, I already have my folder, copying this location. And instead of jumping right into creating a new part, I'm going to head over to this ellipses. Okay, project and settings. Ellipses. This 3 stacked vertical dots. So, selecting settings. Now, I am in my default project. So, in Inventor, it's called actually a project. Okay, and I have some projects here that is already existing. Inventor 2D sketching, sheet metal. So we're going to create a new one. I'm going to select new. So we're asked what type of project are you creating. Again, heading over to this ellipses, selecting settings, and selecting new. Now, what type of project are you creating? We're creating a new single user project. So Vault, for those who are curious what Vault is, it's actually preferred for those large companies or teams. So you have the Vault, the repository. So let's say you have a car. Of course, a car has around 30,000 parts. So nandiyan yung mga, inside there are those parts, those assemblies required for the design. So right now we're small. This is just a training, self-paced, requesting you to create a new single user project. Okay. Shout out to Lawrence Monforte. Going to hit next. Project name. I prefer Inventor. My preference lang naman. Inventor 2025. So, project file to be created. So, again, project workspace folder. It's asked here. I'm going to browse that. Okay. Let me check. So, after browsing, again, I pasted. Notice here, training proper, right? On this prompt. Control V. Hit enter. So it's actually now pointing to my preferred location. Training proper. Again, training proper. Again, requesting everyone to follow along. So selecting finish. So notice under projects, it's checked, meaning this is the active project that we're in. I am in. I'm going to select done. Let me check that folder. training proper. And notice here, a new file was created. It's Inventor, like what I did recently, Inventor 2025.ipj. So it's Inventor project. Okay. Inventor project. So once more, this training is free to our paid participants ng SolidWorks. We actually have an upcoming SolidWorks training, and one of the freebies of that SolidWorks training, you get to know Inventor din as well. So it's two birds, two CAD softwares. And of course, in this first part of our training, we'll be learning the essentials. We'll be starting with 2D sketching, 2D sketches and constraints. So going back, I hope Inventor or the project, Inventor project, was already created. Removing this from view. Okay, so we now have that project created. I'm going to click File, select New. Okay, so I prefer we're going to create, of course, the most essential of all is part. Okay, so I'm going to close this. I don't prefer that type of part creation. Let me show you another one. I click New, or here, create a file from the list of templates. Okay, again, another way is Control N for New. Now, notice here, there's a folder, templates. And if I twirl this down, we have options for English, metric, mold design, old templates. I want you to head over to metric. Just a preference, I prefer working in, for this demonstration or for this training, I prefer standard millimeter.ipt. Okay, again, Control N, create a new file, head over to metric. And because we're creating a part, we're doing sketches. Suggesting you select standard millimeter.ipt. Okay, double left click. Ticky tick. Okay, so it has a count. So notice previously I created the first part. I changed my mind. I created a new part. Is by default is currently named as part 2. Okay, so let's begin with sketches. So currently my view is normal to XY plane. And by default, on this version, the planes are not visible or hidden. So I want you to click or to press F6. So notice my view cube. It's now in isometric view. So this view cube, of course, very typical to Autodesk products. And initially, when we do CAD, initially we're given, I call it 3 papers, okay? 3 2D planes. Of course, when you draw on a paper, it's on a plane, right? So we're given initially 3 papers, and it's named as, by default, as XY. XZ, YZ, XZ, and XY plane. Okay? For those who are absolute beginners of doing CAD, similar to SolidWorks Inventor Fusion. Okay? Let's first be familiarized with the navigation. So I want you to head over to XY plane. Okay? Again, on the browser or the model tree, I want you to click on XY plane. Right click and select New Sketch. So again, our view is normal to the XY plane. Okay? I'm going to cycle over these controls and I want to see the full view of my ribbon. Again, I click this minimize to panel buttons. So again, for the absolute beginner, let's get ourselves familiarized with the controls, navigation. I'm going to click on rectangle. Left click here, left click here. So I'm not too concerned about the dimensions. Again, rectangle tool still active. I'm going to hit escape. I'm going to select finish. So whenever you see this green check mark, it's an indication or visual cue that we are in the sketch mode. So I'm going to click on finish. Okay, next I'm going to hit extrude. So it automatically selected this profile. Let me pull this arrow, giving this a height or depth, and select OK. So as quick as that, we have created a 3D model coming from a 2D sketch. So if for the controls, if I roll out my scroll wheel, so I want you to roll this until it's completely far away. So to bring this back, I'm going to bring this to the full extent of our screen or our canvas. I'm going to double click on my middle mouse. Okay, what I did, double click on the scroll wheel or middle mouse. And to rotate this, it's shift and holding our middle mouse. Okay, I'm rotating or orbiting this 3D model. And to go back to the default isometric view, it's hitting F6. Okay, and if I would like to pan the view, it's holding the middle mouse. Okay, so notice that hand when I'm pressing the middle mouse button. So I'm panning, currently rotating. And if I hit F6, it goes back to the default isometric view. Okay, so feel free, giving you a few minutes, few seconds to be familiarized. Okay, so hope you are familiarized with the navigation already. Okay, next. So notice as well on our model tree, a recording of our actions was made. So initially, pay attention to your left side of the screen. Initially, recall we created a sketch, right? And then we created an extrusion, and that sketch was consumed by this extrusion. Okay? So now, I'm going to redefine the sketch. So if I head over to sketch 1, I want you to head over to sketch 1. I want you to right click and select edit sketch. So again, to our participants, I want you to follow along. I want you to edit this sketch by heading over to our sketch 1, right click and edit sketch. Okay? So, we're now again in sketch mode. So again, the visual cue is this green finish check mark. I'm going to create a window selection. Window. So same with AutoCAD. This is window and this is window crossing. So notice the difference. If window, the selection needs to be, the one will be selected, needs to be inside this rectangular pinkish, okay, pinkish rectangle. So if all of this rectangle is inside this window, everything will be selected. So for crossing, whatever this window hits, so if I create a window selection here, definitely this side, this entity or this line will not be selected. So again, creating a window selection, right click or hit delete. Okay, I want you to select delete. So we're creating a fresh or new sketch. So for Ansharina Janina Del Mundo, yes, we will provide a certificate upon completion of this training. Granted, you are one of our paid participants. Again, this is just a free bonus training to all our paid participants for the SolidWorks training. So after this set of training sessions, we'll be having the SolidWorks training as well. So for the form, to actually register here, I'm going to be sharing the link. It's actually okay. To register in this event or training event, all you have to do is head over to solidworkstraining.digitalcreativeslearning.com. Okay, so going back, we're in the sketch mode. And if you accidentally rotated this, the view, again, we can easily go back to or hit F6. Or, because obviously initially we were in the XY, I can simply head over to the view cube and select front. Okay, so heading to front view. Now, let's create some sketches. Of course, the mastery of part modeling, assembly modeling, it all starts with the sketch, right? Everything starts with sketch. Even those who are in the animation or character modeling, the creative IT. So if you have a character, it all starts with the sketch. So let's say it's the character model will be made in Maya 3D. That 2D sketch can be inserted into Maya to create that 2D into 3D. So it all starts, of course, with a sketch. And for me personally, my definition of sketch is a quick drawing, right? If your boss told you to create a sketch of a table, right? It's a quick drawing of a table. So again, we are in sketch, meaning we have to be quick, or hoping in the future you having the the ability to do quick sketches. So for now, I want you to select line. Obviously, similar in AutoCAD, the shortcut key for that is L. Again, hitting escape to disable that command. So notice if I hit L, okay, this command is highlighted. I want you to left click here, okay, one left click, double left click, and if again, I'm going to create another line, left click, left click, left click, double left click. So again, if I simply do a left click, I am creating a chain of lines. And if ever I wanted to terminate this chain of lines, I'm going to double left click. Okay? So I'm going to delete these lines. Okay, so to delete a line, of course, simply select that line or create a window or crossing selection. So hitting delete. Okay, so this is what we have created so far. And by default, in Inventor, it adds constraints. And those constraints are initially turned off. So if I hit F8 and F9, again, F8. F8 is for the constraints to be visible, and to turn off its visibility, it's F9. Okay, F8, F9. So notice here, if I select F8, automatically one of the lines that I have created, there's a vertical line, vertical constraint. Which means when you say constraint, it's sort of you are shackled, right? This is constrained to be perfectly vertical. So whatever I do, if I select this endpoint and drag this around, select the whole point, dragging this around, it's completely vertical. And again, our set of constraints are located on the top ribbon under constraint. So if I want this not to be perfectly vertical, I can head over here, select this vertical constraint, delete. And notice I can make this diagonal. Okay? So let's add constraints. First one, let's discover coincident. So coincident, I prefer this endpoint and this endpoint to be linked or to be touching each other or coincident with each other. I'm going to select coincident. Okay, selecting this endpoint and this endpoint. So if I hit escape, drag this. Okay, turning off the visibility, selecting this endpoint. Again, I can drag this around and they are completely coincident with each other. So the difference between Inventor and SolidWorks, there's a consistent pressing of F8 and F9 for you to not to accidentally select the constraint itself. Okay? So next, I want this top line to be perfectly vertical. So I'm going to head up, selecting horizontal or the minus sign. Selecting this again to be perfectly horizontal. So same with this line, horizontal. And for this to be vertical, I'm going to hit I or simply head over to our constraints. Vertical constraint, selecting this line. So our objective here is to create a rectangle. So next, I'm going to have these two endpoints coincident with each other. So selecting coincident, selecting this point and this point. hitting escape. Okay, so next, how about creating some two diagonal lines here? Left click, double left click, double left click. So in addition to that, we'll be having an activity, or your assignment. So like for this challenge, okay, for this challenge, so the top horizontal line and bottom horizontal line are actually, they are parallel as well. But of course, another method of making these two parallel is, of course, making them both horizontal. So again, demo for making things parallel, selecting parallel. Notice the constraint symbol. And if I drag this, perfectly parallel with each other. So, question, what is the angle created in a perpendicular situation? Going to hit L, going to create another line coincident with this diagonal line. Double left click. Next, I want this angle, this line and this line to be perpendicular, creating a 90-degree angle. So perpendicular, selecting perpendicular, this line and this line. So again, F8. Okay, zooming in. Notice as well, if I hover over the constraint symbol, it highlights the two entities sharing the same constraint. So this line and this line, of course, are both in perpendicular constraint. So same, if I hover over here, both of these diagonal lines are parallel. Hovering over here, this one is horizontal, vertical. Again, requesting everyone to follow along. So we're currently in familiarization of the constraints. Again, this is very essential. You'll be having difficulty if you go to assembly, to part modeling, if you don't have the grasp and mastery of constraints. Of course, in SolidWorks, it's called relations. Okay, so perpendicular done. Let's say I create a new line again, somewhere around here. Left click, double left click. And my next intent is to have this line and this line, okay, collinear with each other. So the best way to do that is heading over to constraints and selecting collinear constraint. So selecting this line and this horizontal line. So hitting escape, moving this. So turning the visibility off for the constraints. I'm dragging this line on the left. So notice this other side, or this right line on the right, is following the movement, up and down movement of this line, because they are both collinear with each other. Okay? So next, I'm going to delete these lines. So selecting, deleting them all. About creating a circle. So let's create a circle. Shortcut key for that is Control-Shift-C. Control-Shift-C to create a circle. So creating another one here, another one here. Okay? So I want you to create 2 circles. And because this doesn't have any dimensions yet, the diameter is not yet defined for these 2 circles, right? So I can resize them by selecting its circumference, resizing this, placing it here, placing it here. Okay? Again, feel free to experiment, to be familiarized. Taking things slow. Okay, next. So let's discover equal constraints. So selecting equal, selecting this circle, hitting escape, and if I resize the right circle, and because they are both equal, what I do to this right circle is the same. So both are now sharing the same diameter. Okay? Both are now, of course, it applies to everything as well. Same as with lines. So creating 2 lines, another line here. I want them both to be equal in length. So selecting equal constraint, selecting this line and this line. So both now shares the same length. Okay? Deleting these 2 lines. So same as well when you create arcs. So the radius of that, if you apply equal, of course, definitely, both of them would be equal. Okay, going back. We now have discovered the equal constraint. Let's create another circle. This time, it's much smaller. Okay, somewhere around here. Again, requesting everyone to follow along. We now have 2 or 4 circles and a rectangle. So for those who would like to receive a certificate of course completion coming from Autodesk itself, register here, solidworkstraining.digitalcreativeslearning.com. So we now have smaller circle, 2 smaller circles, resizing them. Again, let's apply equal constraint. So selecting these 2 smaller circles. Okay. So next, let's discover concentric. So for concentric, actually, the center points of those 2 circles becomes coincident. That's actually what concentric does. So if I select concentric, selecting this large circle and this smaller circle, so notice the center points of these 2 circles are now coincident with each other. Okay, so again, repeating what we did to the right circles. Selecting this, selecting this. So the last selection will be the destination of the first partner of that circle. Okay? So again, I can resize this. So notice this line is not perfectly vertical. So let me add the vertical constraint to this line. Hitting escape, resizing this. Okay. So next, how about discovering tangent constraint? So selecting tangent. I'm going to select this horizontal line and this circle. Hitting escape. Turning off our constraints, visibility for constraints, F8. Hovering over. So notice this circle and this horizontal line. F9 to turn off. And if I drag this line upward, up and down, okay, so notice the effect of the tangent constraint. So let me apply another tangent constraint as well to this bottom horizontal line and this circle. So I'm going to hit escape. Now if I resize this circle, notice again the effect. I want you to drag and resize. So again, requesting everyone to follow along. If I move or select the center point, notice the effect of that tangent. So let's apply the tangent as well to this other side. So selecting horizontal, the circle, horizontal, and the circle. So if you see that that prompt earlier, a few seconds, so it's mentioning an over constraint, a conflict of constraints. Okay, so next, let me resize this, move this around here. Next, I want you to place the center point at the midpoint of this line, vertical line. So there's actually no midpoint constraint. It is actually located in the coincident constraint. Okay, again, our intent is to have this center point be coincident with the midpoint of this line. So selecting coincident, selecting this center point and this midpoint. So if I hover over this vertical line, there's a green dot indicating that that's the midpoint. So selecting this, repeating the steps here as well, selecting this center point and this midpoint, hitting escape. Let's resize, let's drag, let's check. Okay. I can also create a window selection and drag them all at once. Okay, dragging them somewhere around here. Okay, so notice earlier I mentioned about the 3 initial papers, and recall in AutoCAD when we create a line and we want it to be at the 0 or the coordinates. So remember at AutoCAD we do at 0, 0. Recall that? When we want the line to be placed at the origin, XYZ 0, 0, 0. So the difference with Inventor, we can do that right away. Actually, that 0, 0, 0, the XYZ 0 coordinates, is hidden by default, and it's actually this center point. So notice that yellow dot, that's actually the center point. Okay, and obviously for this sketch or this geometry, the center point of the sketch is of course somewhere around here, the geometric center. Now it's a good practice to have those geometric centers and with the center point, the 0, 0 aligned. But of course it depends on the need. But by default I want you to have that thinking that geometric centers and the origin, it's preferably having them both to be coincident. Of course, in preparation for such things like if I want to mirror this on the other side, I have this center or our plane to be used to mirror this, right? Instead of creating a new line as a mirror reference, by default, let's utilize the existing ones. Okay, so next, the next task would be I want the geometric center of this sketch to be coincident with our center point. So one way I am seeing is to create a line coming from this endpoint going to this endpoint. Next, I want this line, diagonal line, its midpoint to be coincident with the center point. So to do that, I'm going to hit coincident, select coincident, selecting that midpoint, that green dot, left click. And because the center point is not visible, I'm going to head to our model tree and select center point. Again, I have selected center point. So now, this is perfectly at the center together with our center point, 0, 0. Okay? Another way I'm seeing is to possibly deleting that line, align them, align this, the midpoint of this line, align it vertically with our center, same with this line as well. So let's check. I'm going to select vertical constraint, selecting this midpoint and our center point. Let's check. Okay. And I think I'll be having an over constraint if I select this center point and our center point. Okay. So they are actually... So this is why it's important to resize and drag things to check what constraints needs to be applied or what's missing, what needs to be done. So I'm seeing here, I no longer have the need to apply the horizontal constraint. Okay? And notice as well, our entities is in the color of black. Everything is black right now. This is in the color of black. So next, we now have our target shape. Let's now fully define this geometry or this geometric figure by selecting D or heading up again to constrain. On the left side, there's dimension. I'm going to select this. How about selecting these two vertical lines? I'm going to key in 100. Zoom in. Or I'm going to pull this dimension over here. Again, hit D for dimension, selecting this circle, and I prefer the dimension to be 50. So notice the change of colors. From black, it's now dark blue. And the remaining black entities in color black is these two circles. So to turn this into dark blue as well, I'm going to hit D again, define this, its diameter to be 25. So notice everything now is in dark blue. I'm going to hit F6, revolve. Okay, head back to front view. So from here, I can now hit finish sketch. And of course, we have an update. Okay, this was previously a rectangular extrusion. Now it's a sort of slot type. I'm going to hit as accept. Now I am forced to go back to extrusion. I'm going to hit edit feature and reselect these profiles. So these profiles, okay, So again, right click, edit feature, creating a window selection. Again, I have created a window selection. And from creating a window selection, I have selected 9 profiles. And if I have mentioned on 2D, we always prefer things at the center. Same as well in 3D. So I'm going to change the direction to symmetric. Let me drag this arrow. I prefer this to have a thickness somewhere around, what about 10? Okay, I prefer 10. Hitting enter. Hitting F6 for isometric view. So, of course, in design, another thing aside from the only constant thing in this world is change. Definitely in design, there's always changes. May it be from the customers, from your boss, and I hope not from your wife. Okay, so heading back to sketch, let's say there's an update. We're required to have the pitch to be 105. So double clicking 100, double left click again this dimension. Let's say I prefer 110. Hitting enter. So notice it updated, selecting finish, and it's now 110. So I know that because if I select this edge, okay, or under inspect, I select measure. If I select this edge, of course, confirm it's 110. Okay. Yeah, okay. So I want you to of course recreate what we have created. So it's currently 110, 50, and 25. Shout out as well to Sir Anthony Tubera. Okay, again, for you to have a certificate of course completion, later on you need to submit the challenges. Okay, so another update. We have forgotten, we became oblivious to placing the hole on this slot. So we need to go back again to extrusion. Right click, edit feature, and notice on our profiles is currently 9. Again, so right now I prefer removing this additional profiles. So control left click, heading over to the right side, control left click, control left click. So 5 profiles are now under extrusion 1. So we have now created that hole. So selecting OK. Again, I want you to update our activity to an extrusion having 2 holes. So the challenges are actually what I have mentioned verbally. But for those who are, to all paid participants, of course, the challenges, the homeworks will be sent to you through email. Okay, so that's where you can obtain the challenges. So I hope I have answered this question. Yep. Yes, sir. So hoping Anthony Tobera, again, the replay, the high resolution version of this training will be sent to all our paid participants. So hoping you have created this and you have grasp or understanding of how sketch and constraints are very essential to part modeling. So again, notice when we updated this part, everything was made in the sketch. Okay, so let's now move on and let me give you a simple activity. I want you to recreate this 2D challenge. Okay. So let me hit Control N. I prefer this to be in metric, standard millimeter.ipt, double left click. Okay. Again, sketch is a quick drawing. So if I was given this challenge, I'm going to be quickly hitting L for line. I'm going to sketch, I prefer on the XY plane. And I'm going to create this type of sketch. I'm going to create a circle here. So this is my quick sketch of this challenge. And notice as well for this challenge, again, all dimensions are referring to this point, which means I'm going to have this point and that point, which is our center point, coincident with each other. So I'm going to select coincident, selecting this point and our center point. Okay, so next, of course, applying the obvious. This needs to be vertical. I'm going to select vertical constraint. This one to be horizontal. This one to be horizontal. And from here, again, I can now apply the dimensions. So what are those dimensions? 120, 25, and 30. So D, 120, 25. Again, make it a habit. I'm going to hit undo or delete this. What is actually indicated as 25, it's not actually these points. So imagine if this is undergoing QA, I have a caliper and I'm going to measure these two distances. It's actually the caliper will land on this line and this line. So that's why I'm highly suggesting, instead of selecting these 2 points, when you create that 25, you should select this horizontal line. Again, 25. Dimension still active, selecting this line and this center point to be 30. Okay, what else? This one needs to be 45. Okay, showing you again the activity. We're missing the 20 diameter, the radius, that arc to be 20 in radius as well. So again, 20 inside. So D, this one to be 20. And again, the challenge, notice the challenge. It's actually one circle only. So to do that, I'm going to head over to modify. I'm going to select trim. I'm going to trim out this line, this arc, this line, this line. Again, make it a habit to select the entities and move them to check. So moving this. Okay, the question is, my question to our participants, what constraint is needed for this situation? So the answer for that, to prevent this or to have this line aligned horizontally, of course, I have mentioned it now, we need the horizontal constraint. So selecting horizontal. Again, horizontal constraint is not only applicable to lines but to points as well. So selecting this center point and this point. Let's check. Okay, so they are now, these 2 points are now perfectly horizontal with each other, but this one was left out. So from there, if you can recall, we discovered earlier the collinear constraint. So selecting collinear, selecting this line and this line. So checking, moving them all. So what am I lacking? I'm lacking again the 25 dimension. So selecting this line and this line. 25. Next, because I trimmed out that circle, it's now losing its dimension. So again, if you move things, you'll discover what needs to be done. So for here, we need that radius. So for this radius, for this arc, it needs to be 20. Everything now is in dark blue color, meaning if I forcibly move these entities, it won't move because it's fully defined, fully constrained. We're now done with this activity, selecting finish. Okay, and from here I can now extrude this, selecting this profile, selecting symmetric, and feel free to add what thickness you prefer. So I prefer 10. Okay, hitting F6 for isometric view. Okay, so I'm gonna be leaving 2 challenges for you, and on our next meeting we'll be discussing how to create those 2 challenges. It's not actually 2, it's 3 pala. So I want you to screen capture this challenge number 2. Okay, screen capture this, and this would be challenge number 1. Okay, 3. This would be 3. Challenge number 3. So to our participants, again, screen capture this, or feel free to go back to our videos. Okay, that would be 3. And for the last challenge, my challenge for you would be, imagine looking this on this side. I want you to create only the sketch, not in 3D. One sketch only for this 3-part model, 3-part assembly. Again, I want you to create the sketch only for this. So for that one, I want you to screen capture this. Again, it's an additional assignment. I'm going to hit Control N. Okay, let me turn this off. This is what I would like you to do. So I'm creating another part in millimeter. Okay, I'm going to hit Control Shift R. Not Control Shift R. I'm going to hit line. Okay, on the XY plane, and I'm going to select 2-point center. This is what I would like you to do for that challenge. I want everything to be on sketch 1. So no multiple sketches. So for that, recall there's a slot there for this. Okay, notice here. Right, recall. Let me show that challenge once more. Okay. And there's, I'm going to create a line here. Right? And for that peg, going to create a rectangle somewhere around here. Somewhere around here. Creating a quick sketch again. Somewhere around here. Again, showing you the challenge for that second part, which is based from an arc. So I want you to create that arc as well. So somewhere around here, right? We have an arc. So again, for this challenge, I want everything. Notice here, I'm on sketch 1. I'm doing the sketch for this part, and for this part. So I want you to screen capture this challenge, and on our next meeting, we'll be requiring you to submit this challenge. Again, certificate of course completion to be given to those who have completed required tasks. So again, hoping to see you next meeting for the solution and checking of your works and these challenges. Okay, so this challenge, and this challenge.
From the smallest components to the largest assemblies, Autodesk Inventor is the 3D CAD software you need for everyday projects and ambitious challenges. Inventor puts powerful mechanical design, documentation, and product simulation tools at your fingertips to help you innovate with agility, collaborate effectively, and win more business. Inventor provides you with a stable and responsive environment to help you get your projects to production faster. With a complete set of tools for sheet metal, welded frames, tube and pipe, and electromechanical, and direct access to a robust content library and engineering calculators. Shave days off your projects by rapidly configuring products using iLogic design automation technology. Speed up design reviews with a cloud-based tool that protects your intellectual property. Connect directly with AutoCAD for your project workflows. And you can extend the power of Inventor with a subscription to the Product Design and Manufacturing Collection to take your designs further with 2D and 3D workflows, cloud-based design and manufacturing, factory planning, and high-end visualization. Regardless of what you make, industrial machines, conveyor systems, or top fuel dragsters, solve your most interesting problems efficiently and effectively with Autodesk Inventor.
Okay, so one last look. This challenge. Okay, I want you to screen capture this. This one, of course, expecting you have finished this. Okay, and finally this one. Okay, in addition, just an FYI, actually Autodesk Inventor is used in world skills competition, World Skills. So here I am showing you, this is not actually the winner, but I think for the Philippines in the recent Philippine National Skills Competition by TESDA, the winners for gold in Mechanical Engineering CAD category using Autodesk Inventor is from College of Industrial Technology. So hoping we get to train a lot of people too for Inventor, for bringing glory to Philippines. So, okay, so again, yeah, for TESDA and World Skills, Autodesk Inventor is the recommended mechanical engineering CAD software for this competition. So for our participants here, especially the students, we're hoping you get to master this as well. For you to compete in World Skills, for SolidWorks Model Mania 2, and for all our upcoming CAD competitions. So again, congratulations to TUP Manila College of Industrial Technology for the Philippine National Skills Competition. Yes po, Inventor is used for that. So again, see you next meeting, and hoping you have created and will be submitting the required tasks. Okay, so have a pleasant afternoon, everyone. See you on the next session.
A simple project that would have taken 4 hours, we can now do in 20 minutes. And a complex project that would have taken 2 days, we can do in 2 or 3 hours.
We design, manufacture, deliver, and install custom staircases. Every system is new for that customer, so every system is at least a 1/16 of an inch different. We're often one of the last products that gets installed in a home, and if we don't get it right, we can delay them getting a certificate of occupancy. Without iLogic, it took quite a bit to draw even the simplest of orders.
It was very disheartening how much manual labor went into it.
We could draw maybe 1 order a day. We turned to the Autodesk Product Design and Manufacturing Collection. Autodesk Inventor and iLogic has allowed us to automate the engineering or project management process.
A lot of things in stair design are repetitive tasks, and iLogic enables us to automate a lot of those so that a human operator doesn't have to get lost in the minutia.
So let's say, we decided to pull a foot off of that floor, we added a wall there. I would come in and modify the environment here, tell it for length, put in either an absolute, or in this case, if they said we'd subtracted 10 inches, I'd do it. And I would just tell it to update all my glass. It's going to automatically engineer it for me. It's going to make it so that it meets all building codes that our product is certified for, and it's going to generate shop drawings and production prints for these as it goes. It's that easy.
We're manufacturing 10 systems, 20 systems a day right now. With the Inventor CAM, we take the exact model that is part of our automation that we've used to design for the customer, and it's already toolpath. So that production engineer is just posting that right to the machine. It's a huge time savings, and it's a quality assurance. As we build in more and more automation, we continue to drive down potential errors that a user can make.
Welcome to Viewer.
Thank you.
Have a seat. We leverage the Forge Viewer. It enables the customer to view on a web page on their phone exactly what we're engineering and how it will fit into their space.
This looks amazing.
We are now over 10 times the size that we were when we started all of the automation.
Then in the next 5 years, we're going to grow from $100 million a year in revenue to $500 million. Automation is critical for scaling at the rate that we're going. We would not be able to do the things that we are doing today and looking into the future without the Autodesk tools.